This video lecture is meant to help you process the electron configuration practice worksheet, the one that helps you do some applied questions regarding the quantum mechanical model of the atom. So one side of this review sheet looks like this. I think this is the back side, but regardless, we have these questions that say that are trying to show you the key that the configuration for carbon from the periodic table right here is 2-4. The full configuration for carbon is 1s2, 2s2, 2p2. So if we take a look at this, put my pen here. Okay, this 2 right here, the first 2 in this configuration means that there are 2 electrons in the first principal energy level. And this 4 means that there are 4 electrons in the second principal energy level. But there's more information. There's more levels than just the principal energy levels. So there's 2 principal energy levels. But when we break it down, in the first principal energy level, there are 2 electrons, and here's where they can be found. Okay, so this superscript here means that there are 2 electrons in the S sublevel of principal energy level 1. So 1s2 means 2 electrons in the S sublevel of principal energy level 1. Now there are 4 total electrons in the second principal energy level, but the second principal energy level, right, is broken down into 2 parts, this part and this part. And the difference between these 2 parts is the sublevel. So there's an S sublevel and there's a P sublevel. So the idea here is that the first 2 of these 4 electrons always is going to go into the S sublevel of that principal energy level. So we'll have 2 electrons in the S sublevel of the second principal energy level. Then the remaining 2 electrons of these 4 are going to go into the next higher energy sublevel, which is the P sublevel. So this here means that there are 2 electrons in the P sublevel of the second principal energy level. So these right here represent the 4 total electrons in the second principal energy level. And this right here represents the 2 electrons in the first principal energy level. Now there's a further way to shorthand this, and that is to do what's called a shorthand or noble gas configuration. And so if you take a look, this helium right here, this represents a noble gas. Now you know that noble gases on the periodic table can be found all the way over here on the right. Okay, these are all noble gases: He, helium, neon, argon, krypton, xenon, and radon. And the clever thing about the noble gases is, if you take a look, the last number in the electron configuration is an 8. So neon, see this last number here is an 8. Last number here is an 8. Last number here is an 8. 8, 8. The only exception is helium, which only has 2 electrons. Well, that's because it's such a small atom, it can only hold 2 electrons. But the idea here is that these noble gases all have this magic number of 8. It's called the valence number, valence 8, or 8 electrons in the valence shell, the outermost energy level of the atom. And this makes the atoms very, very stable. 8 electrons having a full valence means the atom is stable. It does not want to react. Okay, so these gases do not participate in normal, typical chemical bonding because their valence shells are full. There's no more room to have more electrons go in or out of that shell. They're just happy, they're stable having those number of electrons. Okay, so sometimes to do a shorthand configuration, so if we take a look at where carbon is, right, the 2-4, so this first number 2 that is here in this configuration, this 2 right here, I'm going to try to mark it here with my black pen, right, that 2 represents the 2 electrons that you would have found in helium. Okay, so the helium right here, this notation in brackets, right, is basically saying the same thing as this 1s2 right here. This 1s2 represents what helium would have. So what we do is we put the noble gas in brackets, and then whatever was left in carbon, the 2s2, 2p2, just follows, right? So this isn't much of an abbreviation for helium or for carbon, but you can tell that as the atoms get much bigger, this is going to be a big shortcut. All right, so let's take a look at some of these problems. So sodium, if you take a look at sodium on the periodic table, I'll pull this over here so you can see this, you're going to find that the electron configuration here reads 2-8-1. I'm right here. Okay, so I've written that here. So 2-8-1, how does that, what does that look like in terms of writing it out as a full electron configuration? Well, that 2 right there is the same thing as saying 1s2. You have to pardon me, I'm writing with my mouse pad. I'm not very good at that. Okay, so that 1s2 represents those 2 electrons. These 8 electrons are in the second principal energy level, so we're going to write that as, first of all, the second principal energy level can have a 2s and a 2p. Okay, and so there's only ever 2 electrons that can go into the 2s, so we're going to put 2 electrons there. But there's a total of 8 electrons in the second principal energy level, so we're going to put the balance of those, the 6 remaining electrons, in the 2p. So at this point, the 2s and the 2p are filled. Can't put any more electrons in. So that's why this last electron here, is in the third principal energy level. We're going to have to put that in the third principal energy level. Now, the third principal energy level can have an s, a p, and a d sublevel, but since there's only 1 electron that we have to place, we're going to put that 1 electron in the lowest sublevel available, and that is a 3s1. Okay, so that is what we call the full electron configuration for that. Okay, now iron looks like it's starting out the same way, so we're going to have a 1s2 and a 2s2. And again, I apologize, I'm not really good at writing with my mouse pad and my finger. So far, that right there gives us the 2 electrons and the 8 electrons that we see here and we see here. Now, there's 14 electrons in the third energy level, so we're going to start by putting a 3s and a 3p. And there's going to be enough electrons to go into the 3d. So we can only put 2 electrons into the 3s. We can only put a maximum of 6 electrons into the 3p. Okay, so that's 8 of those 14 electrons. Right? So we're going to have to put the remaining 6 electrons into the 3d. Now, there's 2 electrons in the fourth energy level, so we're going to start by writing the 4, and then because there's 2 electrons, they're going to go in the lowest sublevel possible. So both of those last 2 electrons are going to go into the 4s. All right, so if we continue on with this for bromine, you can see that what we're going to have now is we're going to have a 1s2, 2s2, 2p6. Okay, so far this is all very much the same. Now when we get to the third energy level, it's going to be, we have more room for those electrons to go into the third energy level because the d sublevel can hold up to 10 total electrons. We didn't actually fill it all the way on this previous example. So of those 18 electrons in the third energy level, we're going to put 2 into the 3s. We're going to put 6 into the 3p. That's a total of 8 so far, but we have 18 to place. So we're going to put the remaining 10 in the 3d, and that's the maximum that the 3d can hold. Okay, so now we have to look at placing those 7 electrons in the fourth energy level. So we're going to start by putting 2 of those electrons into the 4s and the remaining 5 electrons into the 4p. All right, so there's a whole lot going on right there. All right, so now what we're going to do is in the space below, we're going to write the shorthand electron configurations of the following elements. So here, what we're talking about right here, this is the shortest electron configuration that you can get. These numbers are coming just directly from the periodic table, just like these numbers did up here, right? So if we go back and take a look at cobalt, right, we're going to see cobalt is 2, 8, 15, 2. So that's why I wrote 2, 8, 15, 2 here. But I want to show you the noble gas configuration for cobalt. So if we look at cobalt, we go up a level and we go all the way over to the noble gases and we see that that is argon, argon containing 2-8-8. Okay, so what we are going to now do is put argon in brackets. That's supposed to be an AR in brackets, right? So argon, which is 2-8-8, is going to take place of the 2 and this 8 here, and then 8 of these 15. Okay, so we don't have to rewrite those, but we still have to place those 7 electrons that are left in that third energy level. So what we're going to now see is that this 8 here was the 3s and the 3p electrons, the 3s2 and the 3p6. So that means we're going to have to put those remaining 7 electrons into the 3d. Okay, so it's going to be 3d7. So that's going to account for the 8 electrons in the third energy level that was in argon, plus the 7 additional in that total of 15. And then there's 2 more electrons, which we're now going to have to place in the 4s2 because it's the fourth principal energy level and there's 2 electrons, and you can only fit 2 electrons into the s sublevel right there. Okay, so let's take a look at silicon. Silicon is right here. If you go up to the row up above it and all the way to the right, we see that neon was 2-8. So we're going to go ahead and pencil in the, if I can do this easily, so this is neon. Well, that's supposed to be a bracket. So this 2-8 is this part right here. So we don't need to write down anything that neon would have, just this 4, which is the third number. So that means we're going into the third principal energy level. So we're going to start with 3s. 2 electrons can go in the 3s, so 2 of these 4 electrons are going to go into this 3s, and the remaining 2 electrons are going to go into the 3p. Fluorine, 2-7. Okay, so here's fluorine right here. Go up a row and all the way over to helium. All right, so we're going to start by writing helium in brackets. Now, the helium only has 2 electrons in the first principal energy level, so this 2 right here represents what helium has. So this is not much of a shortcut, but the helium would be the 1s2. So now we're just going to place these 7 electrons into the 2s. 2 electrons can go in the 2s, and then the remaining 5 of those 7 electrons can go into the 2p. So there you have it. Okay. Now, these next few questions are not quite as tricky. Determine what elements are denoted by the following electron configurations. So what you want to do here is, if you count up the superscripts, that will tell you the number of electrons. The number of electrons will tell you the number of protons. So 2 plus 2 plus 6, that's 10 total, plus 2, that's 12, plus another 4, that's 16. So if we look up 16 electrons, right, we know that that's going to be equal to 16 protons, and we know that the number of protons is the atomic number in the periodic table. So if you go over and find atomic number 16, well, we're going to see that that is sulfur. Okay, so really just count up the superscripts. That's going to tell you the atomic number, which will tell you the identity of the element to be sulfur. Okay. So this next one is everything argon has. Argon has a total of 18 electrons, plus this element's going to have 2 more, so that's 20, plus these 3, that's 23. So we want to look up element number 23, and if we go over here, we're going to have to scroll over to see element number 23 is vanadium. Number 19 is neon. Neon has a total of 10 electrons, plus these 2, that's 12, plus these 3, that's 15. 15 total electrons is going to bring us back over to this side of the periodic table. Whoops. Shouldn't be there. Okay, so over here we can see that 15 is going to give us the element phosphorus. All right, the last problem on this page is going to ask us, or it's not the last problem, but we're going to write the orbital diagram for chlorine in the figure to the right. So 2-8-7, so 2 electrons in the lowest energy level, the principal energy level number 1. So that's this area right here. So there's 2 electrons. Now I'm going to zoom in a little bit, and we're going to see that those 2 electrons are going to go in here, and these are supposed to be oppositely pointing arrows. Okay, so those 2 electrons are those 2 arrows right there. So we've taken care of that first number. The second number, 8 electrons, they're going to go into the second principal energy level. So we're going to have an up arrow, we're going to have a down arrow. There's 2 electrons. Then we're going to go 3, 4, 5, and then we're going to go 6, 7, 8. So there's our 8 electrons right here, and then 7 electrons. I'm going to run out of time here, are going to go 1, 2, 3, 4, 5,